Hello everyone, today let's solve merge two sorted lists. So given two sorted lists, we have to merge them into one. So let's use this as example here. So in the beginning, we will have 4 pointers. The first one is the head of the linked list, the first linked list, the head of the second linked list. And I will create a dummy node here. And the purpose of dummy node is enable us to return the head of the sorted, the merged linked list. And also another pointer called current, which right now points to the dummy. So the algorithm is the following. So we compare the size, the values of two nodes. So and we pick the smaller one. In this case, is either one is the same. So I just assign the second one. Second linked list head to our current next. So current next will point to this node. Point to the node. Because current right now points to dummy, so dummy points to the next, right? Dummy next will become this, will be this node. Okay. And then we just move the pointer to the next node. Okay. And then also move the current to this one, okay, to next node, and then we compare again. Okay. Since one is smaller, so we assign the smaller one to current next. Okay, so assign one to here. Okay. Then we move the smaller node to the next node, and then current node to the next one. And then compare the size, right? 2 is smaller, so current next will become 2, right? And move the node here, and move current to node 2. Compare the size. Okay, 3 is smaller, so put 3 here. Okay, current next will be 3, and move the node here, and move current to here. And then it's the same, so either one is fine. 4 here. Okay, current next will be the node 4, and then move this, nothing to move here, and then current to next one. And right now we only have one of the linked list is empty, so the only thing we have to do is to assign the rest of the node to current next. So in this case, it's here. We just append to next, to current next. And right now you will see why I have to create a dummy node, because dummy next is the head we want to return. So in the end, we just need to return dummy.next, and that's it. So let's implement the code together so you will have a better understanding. Okay. So first thing is the edge case. Whenever you try to solve the algorithm, you have to check the edge cases first. So if L1 is not zero, not nil, but L2 is nil, it means that there's nothing to merge. We just need to return L1. Same as L1 is equal to nil, but L2 is not nil, so nothing to merge. So we just return L2, right? Okay, so edge cases. And then I have to create a dummy node to check the head, right? The purpose of dummy node is to check our head. So I just call it dummy, and then it's a list node, pointer to the list node. Sorry. Okay. So and then what we have to do is to compare the node, right? So as long as L1 is not equal to nil, and then L2 is not equal to nil, we have to compare the size. If L1 value is bigger than L2, okay, so the smaller one first. So we also need the current. Okay, sorry about that. The current points to dummy in the beginning. Okay, So in this case, we have to assign current next will be L2 because L2 is smaller, and then we have to move L2 to next. Okay, and then also we have to move current to next. And else just opposite, right? Means L1 is smaller, so current next will point to current next will point to the smaller one. So in this case, smaller one is L1, and L1 has to move to the next node. Current also move to the next node. Okay. After this for loop, maybe at least one of, because the condition is L1 is not equal to new, L2 is not equal to new. So we have to also check the edge cases, is that one of the node is empty, right? Just like this, one of the node is empty. We have to assign the rest of the node to current next, okay? So if L1 is not equal to new and L2 equal to new, then we just assign L1 to current next. Okay. And if L1 equal to new, but L2 is not equal to new, we just assign the rest of the node to current next. And then because we have dummy points to, like dummy next points to the head we want, so we just return dummy next, and that's it. The time complexity for this algorithm is n plus n, because we have to traverse two linked lists. So the linked list for the first one, the length for the first one, a length for the second linked list. Space complexity is O1. We don't use any extra space. Okay. And then let's submit the code. Yeah, and that's it. Thank you for watching.